This is going to be basic debugging in Lazarus. When a program is started in Lazarus, it creates a memory space called a stack. The stack lasts as long as the program runs. All variables on the stack are deallocated when the program exits. But some variables are too large to put in the stack. So we put them on the heap. The heap is owned by the system, the operating system. Your program asks for the memory, and you must deallocate it. Note, all components that are dropped on the form are deallocated automatically. So why is there a heap and a stack? The stack is fast but limited. 8 meg on a 64-bit machine with a 64-bit compiler. The heap is big but slower. There are two types of variables, global and local. A global variable lasts as long as the program. The local variable only lasts as long as the procedure or function that created it. Integers and strings are created on the stack, so do not need to be deallocated. But things like string list and other classes are created on the heap, so they need to be deallocated if you are the one that created them. We're going to start by creating a form. Press F12 and you will get the form. Now put a button on the form. Send standard button, put in the middle. And then under caption, put run. Now we've created our form. Double click on run. Now we're inside of our run procedure. Now that we've created a form and put a button on it, we want to save our project. We do that by pressing Save All. It will ask us where we want to save the project and what we want to call it. Let's create a new folder and call it Air. Then we'll call our project also Air. You don't need the extension. Then it's going to ask where to put the unit 1. And we'll put it in the same directory we did the others. Now we'll run the thing. So it runs. First thing we're going to do is create a global variable. Now this is a string variable, global, and it's called G variable. This will be created on the stack and will last as long as the program does. Now we go down to our button function, and we can press F12 to get the form to come up. Double click on it. That will get us right in the middle of it. Right next to the semicolon, press enter. And go VAR. This is where we're going to create. Now we're going to create 3 local variables. X is going to be an integer, str is a string, and string list is a string list. As we know, the X and the str are both allocated and given default values, whereas the string list is not. Down here, we're going to use show message to be able to display what these values are. But show message only displays strings. So we will use integer to string to convert the integer to a string. And then there'll be the string, of course. Now down here, we're changing those values. X will be 5, and string will be hat. We're going to use show message again to show it. After that, we're going to create an object called string list. An object is a declaration with memory. It's going to be created based on the class tStringList. And finally, we're going to deallocate all of this memory that we created with string list. Now we're going to save the program and run the program. It says the default value for the integer is 0, but it doesn't show anything here. But there is something here. It's an empty string. Then we changed the values, and now it's 5 and hat. And that's what it does. So after closing the thing, we're going to go down here and look at this. We're going to comment out the string list being created, but we're still going to try to free it. And nothing happens. Now we're going to put the comment back and comment out where we free the memory. And nothing changes. So why is this? It is because we are not using the debug mode. So go to Project Options. Go down to Compiler Options, and next to Default, there's 3 little dots. Press that, and you'll see the option to create a debug and a release. And then click OK. Now, debug will be showed in the window. Then you want to go down to OK. Now run your program again, making sure that these both are not commented out. Press run. Now you can see we got an arbitrary number in here. And this is why you are better off if you initialize your integers when you create them. But 5 and hat. Now when we close this thing, we've got something new. This is what counts. It says 0 unfreed memory blocks. 0. That's what it should say. Then it says the true heap size and the free heap size. And you'll see that one of them is larger than the other. Well, that's because the program still has the stack that's being used. So what you're really interested in is this 0 right here. That tells you there isn't any memory leaks. So now we're going to create a memory leak to see if we can see what's different. Run this. Okay. Now you've got an error. This error says that it raised an exception, a violation message. And then it gives you a bunch of other things. What this is telling you is that you have tried to free memory that never was in use in the first place. So we will go back here and create this, and now comment where we free the memory. We created the memory, but we haven't freed the memory. Now let's see what that gives us. Now you see this big old thing here. This is the part that counts. It says 1 unfreed memory block, 144 bytes. It's telling us that we didn't free the memory that we actually used. And then there's all of this stuff you can look at if you want. Then, of course, there's another one. And now when you're done, if you take out this comment, run it again, you'll see it's back to 0. And that is how you go about debugging a Lazarus program.